Hello, Professor. My name is Rashi Bhavika, and I am here to explain the project for grid integration of energy systems. And this project is for development of a microgrid energy management system using optimization-based techniques. So, with the increasing demands, with the recent world, with the growing demands and the need of energy supply to support the sustainable development, and renewable resources have been emerging recently. To integrate the different types of energy resources, the generation resources of the energy, and the ideas to distribute the energy system, energy, which is called DER, which is designed under distributed energy resources. So to integrate these ideas, this aims towards in reducing the electricity bills and minimizing the consumption from the conventional grid. In this figure, in this is the utility grid, which is in the optimized technique applied here, and this is example three-phase transformer circuit breaker. So the distributed energy resources is being transmitted on fixed load, variable load, solar array, storage energy system. This is the microgrid test system. The microgrid model in here is the two distinct algorithms, which is first is heuristic and the second is optimization. The step-down transformer, which connects the utility grid at the point of common coupling, ECC. In a case study, an average of 450 kW is produced by solar photovoltaic panels, and this is stored in the suggested energy management system, and this details of the databases of all the retail electricity rates are stored under a proper database in this proposed energy management system. Also, that the EMS optimization approach finds the best energy storage system configurations to guarantee the everyday financial viability of residential clients. A comparison is made at the conclusion between the simulation results obtained from two approaches, which is the existing traditional heuristic approach, and the other one is the optimization-based energy management system. The battery charge discharge operation can be effectively managed by the optimization-based energy management system in here, which can reduce the home electricity bill and as a considerable fluctuation in the price of electricity, and which is the main consideration of this management system. This is the architecture of the proposed energy management system. Here we have solar panels, which produces the photovoltaic battery, and we store the power in watts, in joules here, and the energy is the energy obtained from the other electricity resources saved are saved under stop and sorry are saved under energy storage system and then further supplied to residential grid, and this whole filter is obtained. The reduced rates, the bills are generated as electricity tariff, and these bills are after the utility grid microgrid has been applied through the optimization technique. The objective function is based on linear programming, and this has been developed here. The goal of the objective function is a cost function, and it is to reduce the daily cost of residential power. reducing grid utilization as much as feasible within predetermined parameters such as grid power usage, battery energy, and charging discharging levels of the battery and to satisfy these goals. This algorithm converts the battery to charging mode by removing the renewable energy on the availability of the solar energy available. If it is not renewable, it will be sent back in the same for in the original energy format to the main distributed network. The first optimization technique here is heuristic approach of EMS, of energy management system. The out of two scenarios, the first scenario here is EMS, which is operated in the conventional nature, and this is heuristic manner, which we consider one source of energy. For an example, as photovoltaic energy of here, and the power on the both the sides are calculated on the basis when we collect the photovoltaic data from data collection from the grid, and we check the power on both the sides on the measurement of net power. If it's less than zero, greater than zero, on the time of the midday, it is being captured. And if it is at maximum, gaining the more solar energy, so it will be injected maximum power into the battery. So it will put the battery on charge, which will be at the most battery charge ba- power gaining energies storage. If the net power is greater than zero, then the battery is brought into use, and the battery is brought into use under two states: ideal battery ideal level. At ideal level, if the battery is at ideal level, it will till the power of the work the power of the circuit is required. If the battery is 0%, it will go the energy, electricity supply to the residentials will be stopped, and it will result into energy load sheddings. And if the power is going, and it also depends from where the power is coming from, it is being consumed in both the ways. The load shedding, the power electricity supply will be stopped or used utility grid. Utility grid means using the storage system, which is used to conserve electricity at the most requirement times. And this is the energy consumed as in a battery, in a remote batteries, is while we use the batteries, it is the discharging process, which is called the extract maximum power from battery. The energy storage system was put in discharge mode to match the load when the algorithm noticed an increase in load during the fifth hour. The issue starts by measuring the net power using some input data. To summarize the input data from the data collection from grid, it has been distributed in the battery in the charging and discharging format. Based on the quantity of grid energy consumed, the daily total power cost is determined. This flowchart mainly has a goal of attaining the low power bills of electricity. So at the end of based on the quantity of grid energy consumed, the daily power cost is determined. In the other, for the as we have seen the heuristic photovoltaic generation, now we'll move to the process is the optimization based technique for energy management system. In here, we have defined the variables for initializing the algorithm, and we have used MATLAB optimization for toolbox for this simulation. So the very important parameters are calculating the final weight for the energy storage, which this is determined by omega, and considering the prices, the grid power, the energy stored, and the differences between the supplied power and the consumed power, the load, and the energy and the power of the batteries and the energy of the batteries in the respective units of joules and watts. We have uh, we have recorded the maximum and the minimum in this way. We have recorded the maximum and minimum of data from the for the optimize the heuristic model to optimization based model. The goal of the objective function of is a cost function is to reduce the daily cost of residential power. Uh, Very important. These are the very important results for the overall results achieved in both the cases for heuristic method as well as the optimization method. We have considered few parameters like voltage, which is VRMS, and a sock is the supply of at what rate and at what time we are supplying the energy out to the utilities. And price is which we have gotten equal in price in heuristic method as well as optimization based methods. And here we can see that in a heuristic method, the voltage supply was not constant, but the voltage supply in optimization method, though it was not constant, uh, it was at the higher rate and at the higher power as compared to the heuristic method here. And the this graph shows the overall comparison, overall representation of photovoltaic energy on the basis of photovoltaic batteries. It shows the SOC, the grid differences between the heuristic, and here we can see that the SOC is they are we can if we can manually give the supply at the straight level, we can manually manipulate the supply of the energy at the constant rate of slope. And we can also that the grid applied on heuristic method and the and the optimization based method, it is seen that the VRMS, which is constant, which has to be similar in both the cases, shows that the first heuristic method it has the difference is comparatively more, and if we can see, does not follow the graph in the same way. It does not match the graph at the right time. So it is important to give it at the right time, match with the voltage obtained at the right time, and the if we can observe an optimization based technique, we can see that the voltage is similar to the I mean the VRMS is similar to the grid in this graph here. The above results were based on the above results were based on photovoltaic batteries. The energy was stored in watts, and the it was observed that the peak generation was of the photovoltaic energy was at the midday. So before photovoltaic energy was extracted to charge the storage system, the algorithm charged an energy storage system from the grid prior to evening hours. Because the energy storage system during the after post evening hours, it looked for grid electricity at the low cost. The algorithm switched to energy storage system to discharge mode during the evening time when the peak demand has occurred. The peak demand is during the of the electricity is observed to be in the evenings because because we can't get solar power then. So the then the energy storage system discharged until the middle of the night. At the conclusion, the electricity cost was computed to be 983.90 cents per day retail, which is marginally more than the preceding scenario, which was obtained in heuristic technique. The conclusion says that this paper has studied two energy management system algorithms under various electricity rates, considering the residential electricity bill cost. The traditional heuristic energy delivery performs 2.05% better than the optimization method. Inversely, 12.33% less was spent using the optimization method than the heuristic approach. Therefore, the domestic energy scarcity issue may have a workable solution in the optimization-based EMS with the tariff charges. The to construct day ahead scheduling in the future scope, we can say that the single objective linear programming based optimization into a bi-level optimization can be taken into consideration as this model presently state works on the state diagrams and the flowchart programming. Taken into consideration the data from forecasting methodologies and the proposed database in the energy management system. These are the references which I have referred in the whole paper and to make this project. Thank you so much. Any questions, please let me know. Thank you.